Now when we're creating our program, we can notice here that we've got explain. Over here we have our function prototype for explain, we have our function call for explain, and we have our function definition for explain. So that should be fairly straightforward. But one of the things we have to do is take a look at the variables we're going to need here. So we're going to need R1 and R2, and since we're using resistors, typically they're going to be floating point numbers. Serial to parallel, since serial has to equal a character, this has to be a character variable. So let's declare those variables now. And also we need R as well. So let's take a look in putting in our variables. We need float, R1, R2, and R used for resistors, char, ser_parallel. And that's all we really need for our variables here. What we need to do now is after explain we have to get our resistor. So that will be after our explain function. So we're going to say printf input resistor 1. So we're going to prompt the user, and we're going to scanf as it says in our structured diagram, R1, so quote %f quote comma ampersand R1. And because we're lazy, we will do the same thing again. We'll just copy and paste, and we'll change this to resistor 2 and this to resistor 2. And at this point we've got all of this code down to here done. We just have to get a character from the keyboard. And then we're going to scanf %c and then comma, and instead of typing we can just do Control C, go down here, Control V. Let's put in our semicolon at the end. So once we've done that, we want to then say if serial to parallel, we'll just paste it in again, equals quote P. Now we might want to also check for uppercase and lowercase, so we can put another bracket here if serial equals P, or we can say or bracket serial_parallel equals single quote small p. If that's the case, we're going to put a semicolon here, and then we're going to put in else, which is our other case, R equals R1 plus R2. Basically screen gets a printf, and we also have to terminate our program with a pause. And up here we probably want to go to a new line here, \n. Oops, there were build errors. Let's see what's going on. Expected a bracket. Let's take a look and see where that is. We're missing a bracket here. Let's try running it again. It says input resistor 1, let's say 34.2 rather. Let's put in 55.2. Now it said there's a runtime problem, and it mentioned serial_par was not defined. Let's take a look at here. Scanf &R1 &R2. Oops, we forgot to put the ampersand here to scan that. Now there's going to be an issue. When we hit the carriage return on our resistor here, it's going to pick up that enter key here on our next line. So if we say 1 and 1, right away it didn't even ask us for parallel or series, it just went ahead and did the series resistor. We're going to have to then get rid of the enter key, and the simplest way to do that is just do get char. And let's put a comment here, get enter key. Otherwise it sits in the buffer and it's going to be picked up by the scanf. So let's type in 1 and 1. Now it's asking us for parallel or series. Now let's type in small p, and we've got this value here. And as it said, let's run it again. And this time we're going to put in the same numbers 1 and 1. This time we're going to choose capital S for series, and we see that it comes up with this. So when you're finished, you should have this. So there's our explain, R1, R2, serial to parallel, and again we have to do a get char before we do that. There's our if and else, which gives us two possible cases: yes if it's parallel, no if it's series. And then finally we're printing out at the bottom just what the resistance value is. If it's parallel, we do this calculation, print it out. If it's serial, we do this calculation and print it out.